An atom. It's the smallest unit into which matter can be divided without the release of electrically charged particles. It's also the smallest unit of matter that has the characteristic properties of a chemical element. The atom is the basic building block of chemistry, and most of the atom is empty space. The term atom comes from the Greek word for indivisible, because it was once thought that atoms were the smallest things in the universe and could not be divided. As atoms are the smallest units of any chemical element, the number of different kinds of atoms depend on the number of chemical elements as well. There are 118 chemical elements. That's 118 kinds of atoms that are confirmed to exist. Not all of these elements are naturally occurring. There's about 24 elements that are man-made. That's created in laboratory conditions. Reports showed that the first atoms were hydrogen and helium. Still, hydrogen is the most abundant element in the entire universe. The second most abundant element is helium, and the third most abundant element is oxygen. Anything that occupies space is comprised of atoms. And while its name originally referred to a particle that couldn't be divided anymore, we now know that each atom can be divided through the nuclear process. We now know that atoms are made up of three particles known as subatomic particles: protons, neutrons, and electrons, which are comprised of even smaller particles such as quarks. The center of an atom is called the nucleus. It's made up of protons and neutrons. And the number of protons in the nucleus is known as the atomic number. This primarily determines where the atom fits on the periodic table. The number of protons in the nucleus also defines, in large part, the characteristics of the atom. Two atoms with identical number of protons in their nuclei actually belong to the same element. An element like hydrogen, oxygen, or iron is a substance that cannot be broken down outside of a nuclear reaction. It's important to remember that without the exception of a nuclear reaction, one element cannot be transformed into another. Atoms with roughly matching numbers of protons and neutrons are more stable against decay. An important principle to know is electrons may be transferred from one atom to another, or even shared between two atoms. This allows them to bind together. These bonds allow for the formation of molecules out of a combination of many atoms. These include those different elements. Just as several atoms make up a molecule, many molecules make up a chemical. Any element listed on the periodic table consists of specific atoms. Hydrogen, helium, oxygen, and uranium are examples of types of atoms. The idea that atoms are mostly free space is one that creates confusion. If the atoms are essentially naked, for the most part, why can we not go through objects like ghosts? Why do cars not fall directly into the street and to the center of the earth? We have to understand that the empty space, otherwise thought of as completely empty, is actually not empty at all. It's never completely empty. It's full of other interesting things, like invisible quantum fields. You can think of the empty space inside of an atom as a fan in operation. When it doesn't turn, you can put your hand right between the blades. But when it starts, there's a completely radically different situation taking place. If you're reluctant and try putting your hand between the moving blades, you're going to suffer severely. Physically, socially, mentally, it's over. It's the same thing with an atom. Electrons are points, which mean they don't have a volume. They have a wave function, occupying an important part of the atom. And due to quantum mechanics, the electron is simultaneously across that region of the entire atom. In theory, atoms were made about 13.7 billion years ago after the Big Bang. During the Big Bang, the universe was so hot that it was not suitable for forming atoms. And they're so incredibly small that you cannot see them with the naked eye. Scientists were trying to develop for quite some time a microscope that they could use to see the individual atoms, and in 1981, researchers at IBM created a unique type of microscope named the scanning tunneling microscope. And with the help of this device, it was possible to observe atoms for the first time. Today, there are nanoscale microscopes or electron microscopes, which make it even easier to see atoms. People often confuse atoms and cells. It's important to note that cells are made up of billions and billions of molecules, and molecules are made up of atoms. Cells are living things, but atoms are non-living things. That means atoms are much, much smaller than cells. There's about 100 trillion atoms in the average size cell. These are interesting things with JC.